Hey guys, welcome to this lecture on creating Numpy arrays from scratch. In the previous lecture, we looked at two ways of creating arrays. One using the fixed type arrays in Python, using the built-in array module, and the second using the famous Python Numpy package. So just to review what we learned in last lecture, to use the built-in array module, what you do is use import array. By the way, this is going to work in Python 3.3 and above. So import array, and then you're going to define this list here, right? Because we're going to be using this list to create our Numpy arrays, and just apply that list to array.array method. And this I here means integer. So this array is just telling the function that, you know what, this is going to be an integer type. So array.array, pass the list, and then you're going to get this guy here. So this is using the Python's built-in array module. You're going to get this array. And this I here is a code that means integer. So this array is a type of integer. That's what that means. All right. So now looking into the Numpy package, how do you create arrays using Numpy? So by the way, Numpy arrays are built on top of this array module in a way that it's just more efficient to work with Numpy than using the native array module. So yeah, so you're going to do import numpy as np. We always use this alias, as you know, we looked at this specific thing in the previous lecture. So np.array is the method that we're going to use to convert a list into an array. So np.array, pass the list, and then you're going to get this array here, which is an integer type array. As you can see, all the values are integers. Then what happens if it's in the array you have an integer and you also have a float type in the list? So how can you convert that mixed numerical list into a Numpy array? So to do that, just pass into this your usual np.array method, pass your list, and what Numpy is going to do is going to actually upcast all the elements of that list to be a float. So if they are integers like 1, 2, and 3, these will become 1 point, 2 point, and 3 point when you convert this mixed numerical list. Why I'm saying mixed numerical? Because we have an integer type and a float type. This cannot be a string, cannot be anything weird, but only numerical type, right? So that's what I'm calling a mixed numerical type of list. Pass that to np.array. It's going to upcast it. It's going to cast up every element in that list to a float, and then we're going to get this guy here, array with all the elements as float. Because arrays are always single type, so either they can be integer, it can be a float, but they cannot be mixed. That's why. There's one more method we looked at, which was the using the data type dtype attribute of Numpy array. You can specify a data type as float 32. So this is going to take all these integer values and going to convert these values into float. So yeah, that's what we get here. In this lecture, we're going to quickly look at creating arrays from scratch. So I'm just going to do this guy here, creating arrays from scratch. All right, SCRATCH. Yep. So there are multiple routines that Numpy gives you to create some arrays from scratch. For example, you have a thing called np.zeros. It will give you an array of 0 values. Okay. Let's see what's going to happen here. So we can get 10 elements. As you can see, we specified 10 here. They're all of type zeros, right? 0 point, 0 point, 0 point, right? Same way, we can also make a multi-dimensional array. What do you mean a multi-dimensional? Multi-dimensional means it will have rows and columns. Right now, we just have one-dimensional array, which is just one row, right? But we can also make two-dimensional. How do you do that? You can do that by supplying a tuple or tuple in the np.arrays, np.zeros method. By the way, you can let's specify 2 rows and 3 columns. So the first thing is always a row and the second thing is always a column. And now we just gonna press enter, and as you can see, we have 2 rows. Horizontal are the rows and the verticals here, they are the columns. So we have 3 columns and 2 rows. So yeah, there you go. So we have a 0 list with 2 rows and 3 columns. You can similarly with like zeros, you can also play around with ones. We can do 10 ones. This should give us 10 floating value array. and this is one dimensional as you can see it. We can also make it two-dimensional. Again, similar method, np.ones. We're gonna supply, if you imagine you want 4 rows and 6 columns. Press enter. As you can see, 4 rows, 4 horizontal rows, 1, 2, 3, 4, and then 6 columns. And by the way, one more way of checking if an array is a single dimensional or multi-dimensional is by looking at the number of brackets you have in the end, right? As you can see, we have 2 brackets here. That's why it's a two-dimensional array. In the single case, you just have 1 bracket in the end. That's a one-dimensional array. So that's one way of checking that. One last thing I'm going to cover here before we cover some more methods in the next lecture, which is the np.full. So here, what you do is you supply your tuple, which is imagine you need 3 rows and 5 columns, and then you also supply the value you want for the array. So let's see, I want 4, 4, 4. Let's see what's gonna happen. As you can see, this is gonna fill this array with 3 rows, 1, 2, 3, and 5 columns, 1, 2, 3, 4, 5. So you're gonna have 3 by 5 array with values as 4, 4, 4, 4, 4, right? So whichever value you want, you can have same thing here, np.full, and the value can be 3.14, which is the value of pi, by the way. You're gonna have a 3 by 5 array with values 3.14. So yeah, so that's how you create some arrays from scratch. I'm gonna show you guys some more ways of creating arrays in NumPy in the next lecture.